this class, I'll be discussing demand function and demand curve. What is demand function? You remember the law of demand, which states that the higher the price of a commodity, the lower the quantity demanded, and vice versa. That all of that is being equal. In other words, the quantity demanded depends on the price of the commodity. If you know that the quantity demanded depends on the price of the commodity, from this law of demand, we always use the phrase ceteris paribus, meaning that all other factors that can influence demand are held constant. We assume other factors do not change except the price we are dealing with. Therefore, you have to take note of this point. It's never all things being equal, but all other things being equal. All other things being equal means that other factors apart from the factor we are considering, which is the price of the commodity, all other factors are held constant, but the price is allowed to change. Now we are analyzing the impact, that is the effect of the change in price or the quantity demanded. You can also recall that demand is associated with price. Demand is associated with price. If you are asked to draw a demand curve, you will see that you have the price on the vertical axis while you have the quantity demanded on the horizontal axis. This also tells you that the main determinant of quantity demanded is the price of the commodity. So if you know that the main determinant of the quantity demanded is the price of the commodity, although there are other factors that can also affect the demand. Now, these factors, can we express the relationship between this quantity demanded and the price of the commodity and influence the other factors that can affect the quantity demanded? In other words, from the law of demand, we state that the higher the price, that is, the higher the price, when the price is higher, the quantity demanded will fall. And when the price is lower, the quantity demanded will rise. This is simply the law of demand. Law of demand. This law can be transformed into a mathematical equation. This mathematical equation that expresses the relationship between the quantity demanded for a product and the price of the product is known as a demand function. But there is one important thing you need to pay attention to. At times, a demand function may contain more than one independent variable, which is the price. That is, we can say a demand function is a mathematical equation that expresses the relationship between the quantity demanded and its determinant. That is, demand function demand function is a mathematical equation that expresses relationship. That is, it expresses relationship between the quantity demanded for a product demanded for a product and its determinant. One by its determinant, that factors that affect the quantity demanded. Means that is an equation. An equation. That's a mathematical equation that expresses the relationship between quantity demanded for a product and its determinant. That is a demand function. Anyway, so in other words, a good example of a demand function that does not assume any specific form is, you can say the quantity demanded depends, that is a function of P, the price of the commodity. But this does not show the direction of the relationship. It only tells us that the quantity demanded for a product depends on the price, so that is a function of the price. So we cannot guess the direction of the relationship, whether the relationship is positive or negative from this function, unless we are told. For example, we may put a sign here, which is, if I put negative sign here, so that tells me that the quantity demanded is negatively related to the price of the commodity. Okay, but this function is an implicit form. It's an implicit form because it does not tell us the form of the relationship, whether it is a linear form or a non-linear form. So most of the time we use a linear form to represent this demand function. Okay, although there may also at times we may also use non-linear form. Okay, but for convenience sake, so we use a linear function. In other words, an explicit demand function will show the direction of the relationship. In other words, an explicit function can be written as QD equal to A minus BP. A minus BP. So in other words, look at this P is very important. This P here, if I draw a demand curve here, I have P here, I have QD here, and I have 0 here. If I am to determine the slope of this curve here, the slope of this curve will be changing P divided by changing Q. That is going to be the slope. But look at this function, I can derive the Q dp. And the Q dp here is simply minus B. Okay? And this the Q dp is the same thing as changing Q over changing P. That's this equivalent to this. If you compare this and this, you will see that this is the inverse of this. So in other words, this minus B here represent the inverse of the slope of a demand curve. That is, the QDP represent the inverse of the slope of a demand curve. Okay, in other words, if the QDP is equals to minus B, the slope of the demand curve will be equal to 1, that is minus 1 over B. Okay, so this tells us that there is a negative relationship between the price of the commodity and the quantity demanded. Or if you like, there is a negative relation between the quantity demanded for a commodity and the price of that commodity. I hope that is clear. So, we can also express a demand function that contains more than one independent variable. That is, we also have other determinants apart from the price. So let's take a look at that. So now, let's say we can also have QD is a function of, let's say, the price and I, which is income. That the quantity demanded depends on the price and income here. In other words, quantity demanded is negatively related to the price and positively related to the income, that is the consumer income. So this is also an implicit function because it does not show the form of the relationship, whether it's a linear form or non-linear form. Like I said before, we usually use a linear function. So explicitly, this is implicit function, so we can have explicit function that will show the form of that will show the equation form. So in other words, we have QD is equals to A minus BP. Why I say minus BP? Because there is a negative relation between the quantity demanded for a commodity and the price. Then it's going to plus. I'm going to introduce another parameter, which is, I can say C high. Why did I say plus? C high because the relation between the quantity demanded and the price, the relation between the quantity demanded and income is positive. Okay. Therefore, from this equation, just like before, when we have only the price as determinant, the QD equals A minus BP. Okay, here we say this minus BP represents the inverse of the slope of the demand curve. The inverse of the slope of the demand curve, and this A represents the intercept of the demand curve. The intercept of the demand curve. For example, if I have a demand curve like this, okay, so here, this A represents the value of QD when P is equal to 0. You plug in 0 in this equation, you allow P is equal to 0, so all this will disappear and we are left with Q is equal to A. So in other words, this A represents the value of QD when P is equal to 0. So this is P, this is Q. Okay, we want the value of Q when P is equal to 0. So in other words, if I draw a demand curve and allow the curve to touch this quantity demanded axis here. Okay, so this point represents my A. This is A because this is the point at which P is equal to 0. That is the value of Q when P is equal to 0. Okay, hope that is understood. So when we get to the graphical representation of this function, we will get to know it better.